Welcome back, welcome back, welcome back. I hope you're all doing well. Thank you for joining me. In this video, we're going to continue with the 2013 Canadian Senior paper. We're on to question number 4 in A part. We haven't moved on to B part. We're still just looking for that final answer. Let's take a look at question number 4 and what it says. So in the diagram, A, B, C, D, E, F is a regular hexagon, and that means all of its side lengths are going to be the same. And all of its interior angles are going to be the same. They're going to be 120. So it's a regular hexagon with side length 4 and center O. So being the center, it's sort of like the center of a circle, except it's only with these points here. So the special thing, the distance from O to A is the same as the distance from O to C, O to E, and so on. That's what makes it the center. The line segment perpendicular to OA and passing through A meets the extended line OB at point P. So we take OB, we extend it off, and then we have OA, we take the line perpendicular, and eventually those two meet at P. What is the area of triangle OAP? Alright. Well, fortunately, this line segment AP is perpendicular to OA. And right-angled triangles sort of have their base and their height built into the side lengths. So what we should probably try, and this may not work out, but what we should probably try is figure out what the length OA is and figure out what the length AP is. Once we have those, multiply them together and divide by 2. Half base times height, and we'll get the area of triangle OAP. So let's explore this option, and if it doesn't work out, that's okay. We can always come back to the drawing board, but we'll take a look. So it's always a good idea to redraw the diagram so that we can scuff it up on our own. Now, hexagons are pretty tricky. I mean, they're not the hardest regular one to do, but still, this is clearly not a regular hexagon I'm drawing, and that's okay. So we'll say that's point P up there. This is O. This is B. This is A. So we have a right angle here. Okay. So we want a half base times height. Well, that happens to be a half OA times AP. So if we can figure out OAP, we should be home free. Alright. And we know that all these side lengths are going to be the same. And they're all going to be 4. And we know that all of these interior angles are 120 degrees. That's just because it's a regular hexagon. They all have the same interior angle. It's got to be 120 degrees. Okay, so what can we do? Well, let's see what, maybe we can find OA first. Okay. So, to find OA, if I were to drop these lines down here, what I could notice is, since it's a regular hexagon, all these triangles are going to be the same. They're all going to be congruent to each other. They'll all have the same base, and they'll all have the same angle here at O, and the same angles down here, and so forth. But what's really nice is, since O is the center, these lengths are all going to be the same. Okay, and so these angles here are all going to be the same. So I put little dots. Sometimes in other videos I'll put X's or little alphas, but today I feel like little dots to signify that these angles are all the same. So we'll say since it's a regular hexagon, and then we'll write down our deductions. Since it's a regular hexagon, what are some of the things we can conclude? angle AOB is going to be the 360 degrees all around O, but we divide it, they're all equal angles, so divide by 6. We should get 60 degrees. AO is equal to AB, or sorry, BO. It'll turn out that it's equal to AB, but we don't know that yet. So angle OAB is equal to angle OBA. And that's 180 minus 60 degrees divided by 2. So that's going to be 60 degrees. So why is it 180 minus 60 over 2? Well, together these two and 60 degrees add up to the interior angles of a triangle, so they're 180 degrees. So after taking out OAB, what's left over? 120. And both these angles are equal, so we divide it evenly. So we get 60 degrees. So what does that tell us? That tells us OAB is equilateral. Well, what does that mean? Then AO is equal to BO is equal to AB, and we know that as a side of a regular hexagon, it's going to with side length 4, that means it's going to be 4. So already we have AO. Now we just need AP. So let's move on. PAB is going to be angle PAO. We can go back and look at the diagram if we need convincing of this. Minus BAO, well that's 90 degrees. Minus 60 degrees, that's 30 degrees. 30 degrees is one of those special angles, same with 60 degrees. They have very nice sines and cosines, and you'll find they pop up a lot on these contests. Likewise, we know that, well, not likewise, but we know that PAO, which is 90 degrees, and AOP, which is the same as angle AOB, which we know is 60 degrees, plus angle OPA, so that's the sum of the interior angles of a triangle, that's going to be 180 degrees. So 90 degrees plus 60 degrees plus angle OAP or OPA is equal to 180 degrees. So OPA, that's also going to be 30 degrees. And from there we can work out angle PBA is 120 degrees. Alright, so let's just take a look at triangle PAB, who we can now sort of describe entirely in terms of his angles. We know AB is 4, right? It's a side of the hexagon, and we know that the regular hexagon we're talking about has side length 4. We want AP. We've already got AO. To finish this question off, we need AP. So what can we do? We can use the sine law. Okay. So the sine of angle PAB, which we know is 30, divided by, oh, we don't want that one, we want BPA. Alright, this is sort of 10th grade trigonometry, so we should be familiar with it. So BPA is opposite AB, which we know is 4, and we want PA, so we need sine of angle AP or ABP. Okay. Well, that's sine of 30 degrees over 4 is sine of 120 degrees over PA. But sine of 30 degrees, I mean, you can work that out on your calculator, and you can also work sine of 120 degrees out on your calculator, but these are angles you should hopefully know if you are serious about these contests. Sine 30 degrees you should know is a half. Sine 120 degrees you should know is root 3 over 2. The basic angles, 0, 30, 45, 60, 90, and then their counterparts in the other quadrants, are things you should know if you want to do these contests quickly and efficiently. And I'll tell you what I mean, or I'll show you what I mean. The sine of 120, if you were to do that on your calculator, because you don't know that it's root 3 over 2, you'd get 0.86602, yada, yada, yada. And that's all well and good. We could put that in, we could use our calculations. Sine 30 is 0.5 divided by 4, and we could work and rearrange PA. But if we don't know that that root 3 over 2 is there, we think it's just some random decimal, we are likely going to lose marks. Because here's our question. But if we were to scroll up and read all the stuff that you should be reading before you try these contests, calculators are permitted, so that's not a problem, but it's expected that all calculations and answers will be expressed as exact numbers, such as 4 pi, or 2 plus root 7, things like that, rather than in decimal forms. So if we don't write sine of 120 as root 3 over 2, which it is, if we use its decimal of 0.866 whatever, we could lose marks in our final answer, because our final answer would be in decimal form rather than an exact form. Okay, so that's my little pitch there to know some of these angles a whole lot. I mean, if you have a lot of spare time, you can use double angle formulas and memorize sine and cos of 15, sine of 75, that sort of stuff. But the basic ones are 0, 30, 45, 60, and 90. Those are the sines and coses that you should definitely know. All right, well, so returning back to the question, we have 1/2 divided by 4, root 3 over 2 divided by PA. All right, well, we can rearrange this a little bit. And we get 1/8 on the one side is root 3 over 2 divided by PA. Well, we can bring the PA over to this side and the 8 over to this side. PA equals 8 root 3 over 2, so that's 4 root 3. So we have an exact answer for PA. Now, triangle OAP, we already said he's 1/2 base times height. That's 1/2 OA, we know that's 4. And then we have 4 root 3 right up here with the PA. So 1/2, that's 16, so that's 8 root 3. So we get 8 root 3. And if we had done this just with the calculator, if we had just left things as decimal expansions, we would get something like 13.856, but we would potentially lose marks because we don't have an exact final answer when we could have a final answer. If they're expecting decimals, they'll say something like round this to 2 decimals or round this to 4 decimals. If they don't say anything like that, you really need to have an exact final answer. Unfortunately, in this case, we do, and I'll stop harping on about it. So we just wanted area OAP. That's all the question asked for. We have 8 root 3. That's our final answer. So we mark it down in the box. If we needed to, we'd show work. And we're ready to move on to question number 5. So we're over the hump. We're halfway through the short answer portion, but we still have part B looming over our heads, and hopefully we'll get to that soon. But first, question number 5. So thank you for joining. If you like this video, throw a like on it. If you want to, feel free to subscribe for more contest videos. But as always, I'll see you guys in the next video.